Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 4, where we will again solve a problem based on binary search, and the level of this question is going to be medium. The name of this question is find minimum in rotated sorted array. You will get the question link in description, and you can also download this Excel sheet from description as well. So without wasting much time, let's see what is our question. So this is the question on LeetCode. So let's just read it out. So it says that suppose an array of length n sorted in ascending order and rotated between 1 and n times, right? So now I expect that you know what is the meaning of rotated sorted array, because in day number 3 we have solved a very similar problem, right? We have solved a problem of finding searching an element in rotated sorted array. So in that particular day, in that particular video, I had explained you what is the meaning of rotated sorted array. So now I hope that you know what is the meaning of rotated sorted array. If you don't know what is it, then I will recommend you to please go and watch the previous video. Then this particular video will be very easy for you to understand, right? So after it says that, for example, the array is this 0, 1, 2, 3, 4, 5, 6 and 7, and if you rotate it for the 4 times, then this is something what we will get, and if you rotate it for the 7 times, then this is something what we will get. And here they have just wrote the definition of rotation, right, which I had already explained in the previous video, which we have already seen on yesterday. So now let's see what it says further. So it says that given the sorted rotated array nums of unique elements, return the minimum element of this array. So we basically have given rotated sorted array named as nums, and we have to return the minimum element present in this rotated sorted array, and we have to write an algorithm which runs in big O of log n time complexity. So this was the question. Let's understand this question with one example, with one test case. So let's take the same example which we took on yesterday. So the example was 4, 5, 6, 7, 0, 1 and 2. Okay, this is our array, which is a sorted rotated array, and the indexes are 0, 1, 2, 3, 4, 5 and 6. Okay, now if I ask you give me the minimum element present in this array, from your naked eyes you can clearly see that the minimum element is 0. So the answer for this particular test case will be 0. Okay, now the main question arises, how we will solve this question. So the very brute force approach which comes in my brain, which would have also come in your brain, is to do a linear traversal, right? Is to do a linear traversal in the array and then find the minimum element present in this array. Okay, so we can do this very easily. Okay, so yeah, what we will do for this linear traversal, let me just rub it first. Okay, so let's say we have a variable named as mini. Initially it have a very big value, let's say infinity, and we are running a loop from 0 to 6. Okay, so initially our I variable is at index number 0. Then what we will do, we will compare this, we will compare the element present at index number 4 with the mini variable. So we can write a condition such as if ARR of I is lesser than mini, then what we will do, we will do mini is equal to ARR of I, right? This particular condition, right? So what we will check, is this 4 is lesser than infinity? You will say yes. Then this particular line will be executed and we'll put 4 in our mini variable. Okay, so for now the minimum element is 4. Now this I variable will move forward. It will go at index number 1. So what is the element present at index number 1? It is 5. From this particular line we are checking, right? If this 5 is lesser than mini, what is mini? Mini is 4. Is 5 is lesser than 4? You will say no, it is not lesser, so we do not need to update. Then our I variable will go at index number 2, right? And what is the element present at index number 2? It is 6. We will again compare, is this 6 is lesser than 4? You will say no, so again we do not need to update our minimum variable. Then the I variable will again move forward at index number 3. The element present at index number 3 is 7. We will again compare it with 4. Is 7 is lesser than 4? You will say no, so we do not need to update our minimum variable, right? And then we will again move forward our I variable. So I variable will now come to index number 4. Okay, and the element present at index number 4 is 0. We will again compare it with mini. Now say, like, you can see that is this 0 is lesser than 4? You will say yes. Then what we will do, we will just update the mini variable with the 0, right, with this 0 from this particular line of code. Okay, so after doing this, what will happen? After doing this, we will again move forward our I variable. So now I variable will come at index number 5. The element present at index number 5 is 1. We will again compare, is this one is lesser than 0? We will say no. Then our I will go at index number 6. So the element present at index number 6 is 2. We will again compare, is this 2 is lesser than 0? You will say no. So we will not update our mini, and in this way our I will come out of the loop, right? We will come out of the loop, and the final value of mini is 0, which is indeed our answer, right? Which is indeed our answer. So we'll just return our mini variable, right? Now if I write code for this particular approach, then it is going to be very easy. Firstly, we will have a mini variable which will have infinity, and then we will just simply run a loop. Int I is equal to 0 up to n, right? What is this n? N is the size, right? N is the size of our array. Now we will just compare that if the element present at this particular index is lesser than my mini, correct? If this is the case, then we will do mini is equal to ARR of I, right? We will simply put that element in our mini variable, and then at the end we will return our mini variable. So this is the code. This is the code. And what will be the time complexity? Time complexity will be big O of n, right? But in the question it was mentioned that we have to write an algorithm which solves this problem in a time complexity of log n, right? Log of n. Okay, so let's see how we can optimize this. So in the question it is mentioned that we have to write an algorithm which solves this problem in a time complexity of log n, right? And in the question it also says that we have given a rotated sorted array, right? Rotated sorted array. Now whenever we hear this particular word sorted and the time complexity log of n, which algorithm comes into our brain? Yes, you guessed it right. The algorithm is binary search. Why binary search? Because we know that binary search is only applied on sorted arrays, right? And the time complexity of the binary search is log of n. So now we will see how we can solve it, using a binary search. So let's take the same example, 4, 5, 6, 7, 0, 1 and 2, right? So this is our array and the indexes are 0, 1, 2, 3, 4, 5 and 6. Now we will apply binary search here. Now you know how to apply binary search in a sorted rotated array, because we have done this in previous day, so we know how to do that. So initially we'll have a start variable at the 0th index, we'll have a end variable at the last index, and now we'll calculate our mid. So mid is nothing but start plus end divided by 2. So it is 0 plus 6 divided by 2, we will get 3. So now our mid variable would be pointing at this particular index. Okay, now what we will do, we will check that is this left part is sorted or not, right? Yes or not, we will just check it, right? So how to check it is very simple. We will just compare that ARR of start has to be lesser than or equal to ARR of mid, right? So we have 4 here. So is 4 is lesser than or equal to 7? You will say yes. What does this signify? This signifies that this particular portion of the array is sorted, right? This particular portion of the array is sorted. Now let's say I give you one sorted array, right? 4, 5, 6 and 7, a sorted array, and the indexes are 0, 1, 2 and 3, right? And if I ask you to return the minimum element, right? To return the minimum element. Now how you can find the minimum element? See, you know that this particular array is sorted in ascending order, so the minimum element will be present at the starting index of this particular array, right? The minimum element will be present at the starting index, of the sorted array, So from this you can say that you just need to return the element at the starting index of the particular sorted array, and it will be our minimum, right? It will be our minimum. So we will use this same particular approach here. So once we know that this particular portion is sorted, then what we just need to find out the minimum element present in this sorted array. So right now I just explained you how to get the minimum element. Minimum element will be present at the starting index. So what is the starting index? Starting index is nothing but s. So right, initially we will have a mini variable with value as infinity. Now we will compare that the value present at start, is it lesser than r mini? Is it lesser than r mini? So the value present at the starting index is 4. Is it lesser than infinity? You will say yes. Then what we will do? We will just update this mini variable, right? We will write mini is equal to ARR of s, right? And we'll just put this 4 in our mini variable, So in this way, what we have done till yet, in this particular sorted array, from this particular sorted array, we got the minimum element. Now, do we need this particular portion of the array for our further computation? The answer is no, because we already know that this is sorted. And we also got the minimum element from this sorted portion, right? So now this particular portion of the array is of no use for us, right? Because we wanted the minimum element and we got the minimum element from this particular portion. Now what we will do start is equal to mid plus 1. So now our start variable will start pointing to this portion. We'll again compare the mid. So mid is start plus n divided by 2. So it is 4 plus 6 divided by 2. So it is 10 by 2. We'll get 5. Right? We'll get 5. So now our mid variable will be pointing to index number 5. Right? Mid variable will be pointing to here. Correct. Now we'll again do the same thing. We will again check that if this left portion of the array is sorted or not. Right? So we can say that we have 0, right? And it is pointed by start, which it is pointed by s variable, and we have 1 which is pointed by m or mid variable. We'll again check that if ARR of start is lesser than or equal to ARR of mid. So is 0 is lesser than or equal to 1, you will say yes. So it proves that this particular portion of the array is already sorted, right? So now when we know that this particular portion of the array is sorted, then how we will get the minimum element from this sorted array? Yes, it is very simple. So once we have a sorted array, then the minimum element will always be present at the starting index. So the element present at the starting index is 0. We will again compare it with the mini. What is the value of mini right now? It is 4. We will check, is this 0 is lesser than 4? You will say yes. Then we will update this mini and we'll write it as 0, right? So from this operation, we know that we have done our operation in this particular portion of the array. This was sorted and we got the minimum element, right? Now this particular portion of the array is of no use. So again we will do start is equal to mid plus 1. So now our start variable will also point at the same index, and when we calculate our mid, it will be start plus end divided by 2. Start is also 6, end is also 6, and we divide by 2, we will get 6, right? So this means that our mid is also pointing at the same index. Okay, now we will again check the left part is sorted or not, or the right part is sorted or not. So right now for this particular case, we have just one element. Where start is also pointing to this, end is also pointing to this, and mid is also pointing to this. So in itself, this array, this particular part is sorted. And what is the starting index of this sorted array? Starting index of this sorted array will be the value of S, E or M, right? Because S, E or M all are pointing to the same element at the same index, right? So we will again compare. So once we know that this is sorted array, and it has only one element. So what will be the starting index for this particular sorted array? The starting index can be either S, E or M, because all are pointing at the same index. So we'll again compare these two. Is it lesser than mini? What we have in mini? We have 0. So we'll again compare. Is this 2 is lesser than our mini? We will say no. This is not. Then what we will do? We will do start is equal to mid plus 1. So now my start variable will come at this point, right? you can say at index number 7. So at this particular moment, our binary search will be terminated. Why binary search will be terminated? Because in the while loop we will write s is lesser than equal to end, right? And this particular moment the value of s is 7 and the value of e is 6. So now for this, at this particular moment, this condition is not satisfied and will come off the while loop. We will come out of the while loop and our binary search will be terminated. Our binary search will be terminated, and at the end in our mini variable we have our answer. So I hope this particular thing is clear. So let me just show you one more example. Let's say we have 4, 5, 6, 7, 0, 1 and 2, right? We have this particular array and the indexes are again 0, 1, 2, 3, 4, 5 and 6. Okay, so let's say that at one particular moment our mid is pointing at 4 and our start variable is pointing at 0 and our end variable is pointing at 6. Okay, what we'll do, we will again check is this left portion is sorted or not. So what is the formula for seeing the left portion is sorted or not? Very simple. ARR of start, is it lesser than or equal to my ARR of mid? So ARR of s, what is the value of s? Value of s is 0, so we'll write ARR of 0, is it lesser than equal to ARR of m? What is the value of m? 4, so we'll write 4. The value present at index number 0 is 4 and the value present at index number 4 is 0. So is 4 is lesser than or equal to 0? You will say no. What does this signifies? This signifies that this particular portion is not sorted, right? This particular portion of the array is not sorted. So now we know that this particular portion of the array is not sorted. Now if this particular portion is not sorted, then as per the property of sorted rotated array, this particular portion, the right portion of the array will be definitely sorted, right? Then what we will do, we will do start is equal to mid plus 1 and we'll come at this particular portion, right? Start will come at this particular portion, but okay, let's say that our start comes at this particular portion, right? We did start is equal to mid plus 1, we did this, but if you clearly see, we lost our minimum element. Our minimum element was 0 and we lost it. So in this particular case, what we will do, if the left portion is not sorted, then what we have to do is something which we need to understand, right? It is something which we need to understand. Okay, so let's see what was the scenario. We had start pointing at this and we had mid pointing at this. Now if the left portion is not sorted, then the element which is present at index mid, can contribute to my answer, right? Can be my minimum element, Therefore in that particular case we will write mini is equal to minimum of ARR of mid and mini, right? This is something what we will write, right? And instead of this, if you are finding it confusing, then you can just simply write that if ARR of mid is lesser than my mini, then I'll write mini is equal to ARR of mid, correct? So I hope now this particular portion is clear, this particular approach is clear into your head. So let's just write a pseudo code. So initially we'll have a start variable pointing at 0, we'll have end variable pointing at n minus 1. What is this n? N is nothing but the size. We will have mini. What will be mini initially have? It will have initially infinity, right? Then we will write a while loop until my start is lesser than or equal to end. Then my mid will be start plus end minus start divide by 2, right? Start plus end minus start divide by 2. Now what we have to do next? We have to check if the left portion is sorted or not. So for this we will write if ARR of s is lesser than or equal to ARR of mid, right? If this is the case, this means that the left portion of the array is sorted. Then we can write if the ARR of s is lesser than my mini, then I'll do mini is equal to ARR of s, right? ARR of s. And what we will do, we will write start is equal to mid plus 1. If this is not the case, if the left portion is not sorted, it means that the right portion will definitely be sorted. So what we will do, we will again update our min variable, right? We'll update our mini variable. We'll write if ARR of mid m is lesser than my mini, then I'll write mini is equal to ARR of what? ARR of m this time, and what we'll do, we'll go to the next portion, right? So here we'll write end is equal to mid minus 1, correct? And then at the end we will return our mini variable. Okay, so this is the particular approach, right? This is the particular approach, and the time complexity for this approach is going to be big O of log of n, and the space complexity is going to O of 1, right? So let's just code it up fastly. Let me just adjust it. Let me take this down. Okay, so initially we will have n, which will have the size of this array. Then we'll have mini. Let me just assign it with the int max, not int min, with int max. Then we will have a start variable. In start, s is equal to 0, and we'll have an end variable, end is equal to n minus 1, and then we'll run a loop until my start is lesser than equal to my end. Here we will compute our mid variable. So mid will be start plus end minus start divided by 2. Okay, start plus end minus start divided by 2. Now we will just check that if ARR of start, so the name of the array is not ARR, the name of the array is num. So we write ARR of nums of s is lesser than or equal to nums of mid. If this is the case, right, if this is the case, then we'll write if nums of s is lesser than my mini variable, then I'll do mini is equal to nums of s, and after doing this we'll go to the right portion. So we'll write s is equal to mid plus 1. Okay, else what we will do, else we'll again compare that if nums of mid is lesser than my mini, then I'll do mini is equal to nums of m, and after doing this we'll go to the left portion. So it will be end is equal to m minus 1, and after performing this we will just return our mini variable, right? We'll just return our mini variable. So let's see the code once again. So we have n, which holds the size of the nums variable. Mini initially have int maximum, and s is pointing to 0, e is pointing or end is pointing to the last index. Then we are running a loop until my start is less than equal to end. We are computing our medium, right? We are computing our mid variable. Then if the left portion is sorted, then we update our mini variable. If it is not, then we go to the right portion, and we update our mini variable. Okay, so now let's run and let's see it is working fine or not. Okay, so you can see that it is accepted for all the test cases. Now let's just submit this. Okay, so you can see that this particular approach is accepted, and the time complexity of this approach was big O of log of n, because we had just applied traditional binary search, and the space complexity was O of n. So this was all for this video. We will meet again tomorrow with a new problem.